Hello, everybody. This is the second to the last video of calculus ever. Second to the last video. I know you're sad. I know, me too. But let's get this done. These are the integrals of all the trig functions. You want your integral to look like this left side in order to write it like the right side. Make the left look like the right. Notice, it's the antiderivative. If you had written your derivatives down, which you should, by the way, keep a little sticky note of it, the derivative of sine is cosine. The antiderivative, the integral of cosine, is sine. Look at that. Look at that. So please, please, please take a minute, stop this, pause this right now, write all these down. And then might as well write all the derivatives down. And we are going to do about 9 problems of them. You'll have like half the homework tonight and half the homework tomorrow night. So let's go. Integrate 2 cosine x. Well, again, anything that has that constant in front, you can pull out and then just integrate cosine x dx, which fits this form right here, cosine x dx. So you would just write sine and then put your u, which in this case is x. So, but that 2 would stay outside. So 2 sine x plus c. Why do we have to write the plus c? Because this is not a definite integral, but we'll get to that. We'll get to that. All right, what about this one? 3x squared sine x cubed dx. Oy. So what do I do here? Well, there's probably going to be a u in this problem. What do you think our u would be? Probably next to the sine, usually. I'm going to show you ones where it's not. So we're going to call that u, x cubed. And we're going to take the derivative of it, which would be 3x squared. Then we're going to multiply by dx on both sides. So du is equal to 3x squared dx. Hey, I have that. I'm actually going to circle that out. Make my little shape right here. Cross this off. You're going to call that du. And then that would be your u. So when you go to rewrite it, it would look like the integral of sine u du. Once it looks like this, you write it like this. You have to make it look like that. You have to have the integral for sine and its derivative, which is in this case is du, minus cosine u plus c. So this would equal negative cosine u plus c, which is negative cosine of, what's my u? X cubed plus c. Okay? So we're always, always, always looking to find out what our u is and is the derivative inside the integral. Let's do another one. The integral of secant 3x tan 3x dx. Secant 3x tan 3x dx. Okay, so again, let's look and see if that fits anything. Oh, secant u tan u du. Okay, so what is my u in this case? It's the both of these. These are both the u. They should both be the same. Okay, you don't want something that's different. So u is 3x. The du would be 3dx. I don't have a 3, so what do I do with that 3? Well, I have to divide by 3. So a third du is equal to dx. So let's rewrite this. This guy right here, I am now going to replace with a third du. This and this are both my u's, because that's what the formula says. So 1/3 secant u tan u du. That's what we're going to integrate. Does that look like the formula over here? It does. Again, that 1/3 that can just go in front. So the integral of a secant tan comes out to be secant. So the integral of this with the 1/3 in front would just be secant u plus c. But now you plug in your u, which would be 1/3 secant 3x plus c. Easy peasy. Let's look at this one, the integral of e to the x secant squared e to the x. Let's see if there's an integral for secant squared. There is. The integral of secant squared is tan. Actually, that should say tan u. I hope you all realized that when you copied it. Meh. All right, so what would be my u then? Well, this would be my u. So u is e to the x. What's the derivative? What's the du? Oh, it's e to the x dx, which I have. Cool. Take that, cross it off, replace this. Let's rewrite all this. This now is my du. So I'm going to rewrite this. What's in purple is going to be integral of secant squared and then a u, and then put du. And again, the integral for secant squared is tan u. Sorry that I forgot that, tan u. So it would be tan u plus c, or in this case, what's my u? Tan e to the x plus c. Okay, so let's do this one. You're looking at it and like sine squared 4x cosine 4x. So let's look my list here. Do I have a sine squared 4x cosine 4x? Sine squared, sine, secant squared. Oh, I don't. Okay, so what am I going to have to do now? Well, my u is going to be different. My u is not going to be just 4x, okay? It's not going to work. It's going to have to be something else. So your u, remember, is usually your power. Usually our power. So if I were to rewrite this, this is actually, remember, sine of 4x squared cosine 4x. So I'm going to let my u be this entire thing because that's being raised to the power of 2. So u is sine of 4x. What's the derivative? What's the du? Again, you have your little sheet here. The derivative of sine u is cosine u. Now this is going to be hard for you to remember. It's not just cosine 4x, it's cosine 4x times the chain, 4, or 4 cosine 4x. And then don't forget dx, because we multiply by dx on that side. So do I have that in my problem? Well, I almost have that. I have the cosine 4x dx, but what do I do with that 4? Got to divide it out. So 1/4 du is equal to cosine 4x dx. Y'all caught that? If not, rewind and go over this problem again. It's very important. So this right here, I'm going to cross it off. I'm going to call it 1/4 du. This, what's that called again? That's u. U squared. And so now I'm actually integrating 1/4 of u squared du, which truly has nothing to do with this at all. You're just integrating 1/4 of u squared. How do you do that? Well, you add 1 to the exponent and divide. So 1/4 u to the third divided by 3, which would be, plus c, which would be 1/12 u to the third plus c, and then replace your u. So that would be 1/12 sine of 4x to the third plus c. You could obviously call it sine cubed 4x, but okay, very important. There was an example where your u wasn't next to the cosine. It was actually the entire thing. It's, again, usually whatever has power. Okay, getting done here. Tan of 4x, tan of 4x. Let me just check real quick. Tan, yeah, I can change that u. So my u in this case would be what's next to the word tan. My du would be 4 dx. I don't have a 4, but I have a dx, so I'm going to divide it over. I'm going to rewrite this as, I'm just going to rewrite the 1/4 in front. Tan, this is my u, that is my du. And then integrate tan, integral of tan is negative ln absolute value of cosine u plus c. Okay, so how do I write that? So it'd be negative 1/4 ln the absolute value of cosine u. What's my u? 4x and then plus c. Easy peasy. All right, let's do this one. Integral of sine over cosine. So what is sine over cosine, everybody? You remember what sine over cosine is? Yes, it's just tan. It's a trig identity. If you have a trig identity, you might as well try to find it and rewrite, because again, it's easier to integrate something simpler than that. So we found our trig identity. It's just the integral of tan. What's the integral of tan? Well, that's that negative ln cosine u. So it would just be negative ln cosine x plus c. You could have actually, if you notice this, called this your u, cosine. Your du would have been sine. Then you would have had the integral of 1 over u. And what's the integral of 1 over u? Ln. I think there's a negative in there that I know I'm missing, but it would have worked out. All right, almost done. 2 more. Tan to the 5th x secant squared x dx. Now, again, when I look through my whole list here, I need a tan to the 5th secant squared. I see a secant squared. I don't see a tan to the 5th. So what that probably means is that I probably have an entire trig function that is a u. So again, if I were rewriting this, this would be the integral of tan of x to the 5th secant x squared dx, okay? So which one do I want to let my u? Probably the one with the higher power. It's usually the one I choose. So let's let u be tan x. The derivative of tan, let me go to my little yellow sticky note. The derivative of tan is secant squared. Well, that's great because that's what I have. Secant squared x, put a little dx. So this right here, secant squared dx, cross it off and call it du. This tan x to the 5th is just u to the 5th. Oh, so I don't need this sheet at all. Yes, just really needed to know about derivatives. How do I integrate u to the 5th? That would just be u to the 6th over 6 plus c. The 6th over 6 plus c, which is tan x to the 6th over 6 plus c. Simple. Last one. What have I done right now? What have I done? I've defined it. Okay, this is now a definite integral. So what would be my u? Again, do I have an integral for a cosine? I do. The integral for cosine is sine. Okay, so then this is going to be my u. So my u is 2x. My du would be 2 dx. I don't have a 2, but we know what to do. 1/2 du equals dx. Cross that off. Call it 1/2 du cosine u. We just replaced everything from 0 to pi over 4. Now, when we integrate, the integral of cosine u is sine u, so that 1/2 just stays in front, sine u. And we don't put plus c because we're going from 0 to pi over 4. So we just write it like that. But of course, I want to replace my u now. So this would be 1/2 sine of 2x from 0 to pi over 4. And let's see if we can talk about that. Let's see if we can actually do this. Remember how to do this? Okay, this is fundamental theorem of calculus. Plug pi over 4 in where you see x. So it would be 1/2 sine of 2 times pi over 4 minus, now you plug 0 in, 1/2 sine of 2 times 0. And what is sine of 2 pi over 4? Really, what's sine of pi over 2? What's sine at 90? Yeah, it's 1 times 1/2, which is just a half. And then what's the sine at 2 times 0? What's the sine at 0? 0 times a half is 0. So it's 1/2. You can double check that on the calculator. All right, your next 2 assignments deal with this. Hope you enjoyed it. Oh my gosh, next video is our last lesson. Bye.